Hello, welcome back to the channel. So let's continue our previous videos and do one more question on solving indefinite or definite integrals using partial fractions. So again you see a factored out term in the denominator. You know that x square minus 1 can be easily simplified to x plus 1 times x minus 1. So again you see factored out terms in the denominator, which gives you an idea that it would be easier for you to solve this indefinite integral using partial fractions rather than using any other method that we discussed in the previous videos, right? But there is indeed one catch about this question, that in order to use partial fractions, whatever degree of the polynomial is in your denominator, your degree of the polynomial in the numerator should be at most 1 degree lesser than the degree of the polynomial in your denominator. Which means, for example, in this case, we have an x square minus 1 term in the denominator, which means that the degree of this polynomial is 2, which means in this case that in the numerator we can only have a polynomial of degree with at most 1 in this case. So since you have x square expression in the denominator, in this case you will have to simplify this expression, and after simplifying this expression you can have either a constant term in the numerator or also a linear polynomial in the numerator, because you are only allowed to have the polynomials of degree at most 1 in the numerator in this case, right? Don't worry if this seems complicated at this time. We'll do this whole question and then we'll get a very good idea about what we meant by simplifying this expression further and then using partial fractions, because we cannot use partial fractions on this expression over here, because in the numerator the degree of the polynomial in this case is also 2, which is not allowed in the case of partial fractions, right? And you would have also noticed this pattern in the previous videos as well when we did these previous questions. So in this case as well, in the denominator the degree of your polynomial is 3, right? Because you'll have, if you solve this expression over here, you'll have an x cubed term, so the degree is 3, but in the numerator the degree is 1. So this is totally allowed if you want to use partial fractions. And again in the previous question as well, you can see the same pattern over here as well, right? In the numerator the degree of your polynomial is 0, but in the denominator your degree of the polynomial is 2 in this case, right? So now we'll have to further simplify this expression so that we can have at most 1 degree polynomial in the numerator of this expression. So what we'll do is we'll use long division to do that, and we'll divide this expression with x square minus 1. So if we divide this expression with x square minus 1, it would be simply dividing 5x square minus 3x minus 1 by x square minus 1. And you would be already familiar with the long division methods, right? So we'll multiply this expression by 5 because we want a 5x square term over here. So if we multiply this expression with 5, we'll get a 5x square term, right? So if we multiply it by 5, this would become 5x square, and this would be minus 1 times 5 would be minus 5 in this case, right? And then we'll subtract these terms, so minus and plus over here. This will cancel out. Minus 3x, you have minus 3x over here, which will remain as it is. So minus 3x, and then minus 1 plus 5 is plus 4, right? And you already know the division formula, right? We know that dividend is basically quotient times divisor plus remainder, right? So dividend in this case is 5x square minus 3x minus 1. So 5x square minus 3x minus 1. Quotient is this one. So 5 is the quotient. 5 times divisor is this one, x square minus 1. And then your remainder is basically this expression over here, right? So your remainder is plus minus 3x plus 4, because this is your remainder. And now since you want this expression to be simplified for your integral over here, right? Let's divide this expression, the left hand side and right hand side, with x square minus 1, right? And we are only doing that because we want 5x square minus 3x minus 1, which is over here, divided by x square minus 1, right? So if we do that, 5x square minus 3x minus 1 divided by x square minus 1. So the first term will become just 5, and the second term would be minus 3x plus 4 upon x square minus 1 in this case, right? And now you can clearly see that this expression over here is simplified to this expression over here. And now the degree of the polynomial in the denominator is 2, but the degree of the polynomial in the numerator is 1, which is allowed if you want to use partial fractions in order to solve for this integral expression over here, right? So that is why if you are calculating the integral of this expression on the left hand side, you're doing integral dx. So this would be simply integral 5 dx plus integral of minus 3x plus 4 upon x square minus 1, right? And now again, if you want to use partial fractions, we know that we can simplify this expression. So minus 3x plus 4 upon x square minus 1. Let's first simplify this expression before doing the indefinite integrals over here, which we already were doing in the previous videos as well when we were using partial fractions. So we know that we have factored out terms in the denominator. So this can be easily converted to minus 3x plus 4 upon x plus 1 times x minus 1. And now because of the partial fractions, you know how to break down this expression into individual components. So you can write minus 3x plus 4 upon x plus 1 times x minus 1 as simply a upon x plus 1 plus b upon x minus 1, right? And now you can solve for your a's and b's in order to simplify this expression into these two individual components over here. So let's do that. And now if we do that, we can compare the numerators. So on the left hand side, the numerator is this one, but on the right hand side, the numerator would be a times x minus 1 plus b times x plus 1, right? So this would be ax minus a plus bx plus b. And now combining the similar terms together, it would be x times a plus b plus minus a plus b over here, right? And now if you compare the similar terms, you'll easily get a plus b as simply minus 3. Your minus a plus b over here is 4. And now if you'll add these two terms, you can clearly see 2b is 1. So b is half. If your b is half, from this expression, we can calculate a. So minus a plus half equals 4, which means minus a equals 4 minus half. So minus a equals 7 by 2. That means a is equal to 7 by 2 in this case. So now you have your a, you have your b, and now this expression over here can be easily simplified to the right hand side over here, right? So this expression will then become simply your a is minus 7 by 2. So this is minus 7 by 2, 1 upon x plus 1 plus your b is half. So it would be half 1 upon x minus 1 over here, right? So now you converted this expression successfully to this simple expression over here. And for the original integral, you were basically calculating this expression. Again, we can transform the right hand side to an even simpler expression, which would be simply integral 5 dx plus this integral over here, right? So integral of minus 7 by 2 times x plus 1 dx plus this integral over here, right? Plus integral of 1 by 2 x minus 1 dx in this case, right? So now if you want to calculate this expression, the integral of this expression, you can easily calculate the integral of this expression, the right hand side over here, and you'll get the same answer for the integral on the left hand side. And now you can realize how easy it is to calculate this integral over here rather than solving this complicated integral over here. And again, in order to do that, we use some basic concepts of long division and also the concepts of partial fractions, which we already covered in the previous video. So that's it for this video. Again, the main takeaway from this video is that whenever you are using partial fractions, whenever you identify that you have factored out terms in the denominator, always check for the degree of the polynomial in the denominator and also in the numerator. And the relation is the degree of the polynomial in the numerator should be at most 1 lesser than the degree of the polynomial in the denominator. So if in the denominator your degree of the polynomial is 2, in the numerator you're only allowed to have the polynomial of degree with at most 1 in that case, if you want to use partial fractions. Right? I hope that makes sense. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.